Whether it's classification or regression, given the data points, you can come up with any number of models to explain the underlying pattern in your data. So for instance, in case of classification, you can have any number of decision boundaries that will explain your data. Or for regression, you can have any number of curves which can be used to represent your underlying data. So how do we decide which one is the best model? So the way we do that is through a process called cross-validation. So given your original data set, let's say with the set of input features and expected outputs, what we do is we take this original data set and split it. We randomly sample a subset of this data set and call it the training set. Generally, we put, depending on your situation, you might have around about 70 to 80% of your original data in this training set, and the remaining data points will be ending up in your test set. So what we want to do is keep this test set aside and not to have it mixed while we are training our models. So the process of n-fold cross-validation splits the training data set into n folds. So what we do is create a subset, n subsets of this data set. So let's say for 5-fold cross-validation, we will split the data into 5 equal sized portions. And when we train our model, during training, what happens is, so this is our regression model that we are currently considering. So for each regression model, we train it using n minus 1 folds. So this is used to train it, and it is evaluated, or rather cross-validated, against the remaining fold. So in this way, each model gets trained 5 times. Once again, how is that done? Well, we train the model on 4 folds and it's tested on the remaining fold. In the next round, we keep this fold aside for cross-validation and train it on the remaining 4 folds. Third round, we keep this guy aside and train it on this remaining sets. Fourth round, we keep this guy aside for cross-validation and train it on the remaining set, and so on and so forth. So in this way, you will get an average cross-validation accuracy that tells you how well the model is doing. So in this way, every model that you have, so in this case, we had 3 models to consider. For each of the 3 models, you will do 5-fold cross-validation, and whichever model has the highest average cross-validation accuracy, that model gets selected. So that will be the model. We had here 3 models to consider. We started off with 3 models, and after cross-validation, we picked the best model. And this best model, the resulting best model, is then going to be tested using our test data. So this gives us our final accuracy, which tells us how good our model is with respect to unknown data.